Hilchos Kiddush Hachodesh, Perek Yud Zayin. This class is dedicated to Nishmas Eliyahu ben Pinchas and Avraham David ben Yisrael. Perek Yud Zayin of Kiddush Hachodesh is no doubt the most complex Perek in these halachos, simply because it's the most loaded. Every 2-3 halachos is another adjustment, another correction, each requiring their own background to understand them. We'll take it step by step, and Be'ezus Hashem will make it through it all. Going into Perek Yud Zayin, we carry with us the results of the last few prakim. We know that the question at the core of these halachos is whether the moon will be visible in the sky after sunset on the night following the Mailid. The answer to this question, of course, depends on the distance between the sun and the moon. If they're far enough from each other, then after sunset, after the sun has dipped below the horizon, there will still be sufficient time for the moon, which is still above the horizon, to be seen from Earth. If they're not far enough, then of course the moon will not be seen. We've discovered in the last few prakim that when we talk about the distance between the sun and the moon, there are two elements to this distance. There's the distance of oirech, longitude, east to west, and there's the distance of rochav, latitude, north to south. Before we begin any calculations, we have to first determine these two distances. That's why right in the beginning of Perek Yud Zayin, the Rambam says, if you want to start anything, you have to first figure out the distance between the sun and the moon in longitude. That's called the oirech rishon, the first longitude. The reason why it's called first is because it will be adjusted multiple times throughout this Perek, leading us to the oirech sheni, shlishi, and revi. But essentially the fundamental word here is oirech, the distance in longitude. And you have to also figure out the distance in latitude, the rochav. Again, the Rambam calls this the rochav rishon, the first latitude, because it will be adjusted later in this Perek to reach the rochav sheni. But the important word is the rochav, the distance in latitude. After you've determined oirech rishon and rochav rishon, you're ready to go further. But before we go deep into the calculations, the Rambam makes a preliminary point. He says, take a look at this oirech rishon. Figure out this initial distance between the true position of the sun and the moon. If, and here are the Rambam's words, if the moon is anywhere between the mazales of Gedi and To'imim, that means between 270 degrees and 90 degrees, then the oirech rishon has to be in a specific window for it to require further calculation. If the distance is below 9 degrees, don't bother, the moon won't be seen. If the distance is above 15 degrees, don't bother, the moon will for sure be seen. Only if the distance is between 9 and 15 degrees, then you have to go further with all the calculations. In a similar way, the Rambam says, in the other half of the Galgal HaMazales, if the moon is between the mazales of To'imim and Keshes, the window is a bit different. If the distance of oirech rishon is below 10 degrees, don't bother, the moon won't be seen. If the distance is above 24 degrees, don't bother, the moon will for sure be seen. Only if the oirech rishon is between 10 and 24 degrees do you have to go through the headache of all the future adjustments and corrections. Why is there such a difference between these two halves of the Galgal HaMazales? That on one half the window is 9 to 15 degrees, and on the other half it's much bigger, from 10 to 24 degrees. The reason is as follows. The Galgal HaYomi pushes all of reality from east to west. The sun and the moon are progressing from west to east. But as we've explained multiple times, they're not progressing directly from west to east. They're progressing on a little bit of an inclination, which means that from the mazales of Gedi to To'imim, the sun and the moon have a northerly orientation. They're climbing upwards. So while they're generally going towards the east, they're really going, for the sake of accuracy, northeast. In the same way, on the other half of the Galgal HaMazales, when they are on the mazales of To'imim, or really Sartan, till Keshes, they have a southerly orientation, which means, in general, they're heading eastward, but really, for the sake of accuracy, they're heading southeast. Why does this matter? We talked in the last class about the fact that Kiddush Hachodesh, all of these halachos, are centered around somebody standing in Yerushalayim. For somebody standing in Yerushalayim, the more northerly something is, the later it will set on the horizon. The more southerly something is, the earlier it will set on the horizon. So when it comes to the night following the Moiled, we know for sure that the moon is heading eastward away from the sun. And for that reason, its setting will be delayed. The moon is going to set after the sun. However, the question is, how much later? If the moon is in the mazoles that have a northerly orientation, they're also called in the Mefarshim mazoles oilim, mazoles which are ascending upwards, northwards, then that means that while the moon is going east, away from the sun, it's also going north, which is pushing it even to a later point on the horizon. So its shkia, its setting, will happen later. If the moon is on the southerly oriented mazoles, also called in the Mefarshim the mazoles yerdim, the descending mazoles, because they're descending southward, then even though the moon is heading eastward, away from the sun, thus delaying its setting, but because it's going south, heading to a point on the horizon where shkia is earlier, the delay is not going to be so big. Therefore, the Rambam says, if the moon has a northerly orientation, then once you hit 15 degrees of distance, you can be sure that the moon will be sighted, because the shkia is going to be later, the shkia of the moon, that is. If, however, the moon is on a southerly oriented path, then it requires 24 degrees to be sure that the moon will be seen. Anything less than 24 degrees is going to force you into the cycle of adjustments and corrections. Before we get to the details of the adjustments and the corrections, let's put out the lay of the land. What's actually happening in this Perek? So I'm going to go through all the technical terms right now, and then we're going to unpack each of them individually. Essentially, there are going to be 4 layers of adjustment. The first is called Shinui Mare. Shinui Mare is going to create an adjustment both to the Oרך and to the Rוחב, both to the distance in longitude and to the distance in latitude. This will lead us to the Oרך Sheni and the Rוחab Sheni, the second longitude and the second latitude. Then there's going to be a correction that's called Magal Hayareach. Magal Hayareach is only going to correct the Oרך, leading us to the Orych Shlishi, the third level in the distance in longitude. Then there's going to be another correction, which the Rambam does not give a technical name to. We'll call it the difference between the equator and the Galgal Hamazoles. And that difference is going to put another layer of correction on the Orych, leading us to the Orych Revi, the fourth distance in longitude. Finally, there's going to be an adjustment called Minas Goiva Hamedina that's going to bring the Orych Revi to Keshes Haraia, the final arc, the final angle of sighting, the final distance between the sun and the moon. At the end of the Perek, you take the Keshes Haraia and the Orych Rishon, which means the final level of longitude and the first level of longitude, and you compare the two for the final verdict of whether the moon will be sighted. Now let's go back and discuss each of these adjustments in order. The first, as we said, is called the Shinui Mare, the difference in sighting. And what this means is as follows. All the corrections in the previous prakim that brought us from the Mokim Emtsoi to the Mokim Amiti, from the mean position to the true position of the sun and the moon, were all computed as though the viewer were standing in the center of the earth. However, in truth, the viewer in Yerushalayim is on the surface of the earth, not in the center. The distance between the surface of earth and the center of earth is about 4,000 miles. That has an influence both on the Orych and on the Rוחab, both on the longitudinal difference between the sun and the moon and the latitudinal difference. Let's start with the Orych. Without getting into the mathematics of it, the fact that the viewer is not in the center but rather on the surface of earth will cause the moon to always be seen more westward than it might originally be. Westward means closer to the sun. Remember, the moon is climbing away from the sun eastward. So if you're saying that you're pushing the moon to the west, that means you're bringing it closer to the sun. In other words, the Orych Rishon because of the Shinui Mara, is going to get smaller. That's what the Rambam gives us in Halachos Hey and Vav, the exact amounts to subtract. There's a little bit of a difference in the subtractions depending on which mazel the moon is in, since each mazel is viewed from Yerushalayim at a different angle. That's as far as the Shinui Mara's influence on the oirech, on the distance in longitude. But the Shinui Mara also influences the observation of Rochav hayareach, the difference in latitude. Remember, the moon's inclination relative to the equator is a maximum of 28.5 degrees. The Galgal HaMazoles is inclined at 23.5 degrees, and the moon is inclined maximum another 5. However, Yerushalayim is 32 degrees north of the equator. So if you could look at the universe from the outside, North Pole on top, South Pole on bottom, Yerushalayim in the middle there, you'll see that a person standing in Yerushalayim is always, so to speak, looking down at the moon, since they're standing higher than the moon's maximum inclination. Or said in short, to someone in Yerushalayim, the moon will always appear more southerly than it actually is. Hence the Rambam says that if the Rochav hayareach is northerly, we will subtract from it, decreasing the latitudinal difference between the moon and the Galgal HaMazoles. And if the Rochav hayareach is southerly, then we will add to it, increasing the distance between the moon and the Galgal HaMazoles. By the way, this could potentially increase Rochav hayareach to more than 5 degrees, even though the moon itself is only inclined at 5 degrees, but from the viewer's vantage point, the moon could look even lower, up to a maximum, as we see in the Rambam, of 1 degree for a total of 6 degrees. Either way, the net effect is the same. The point of Shinui Mara HaRochav is always about making the moon more southerly to match the way we see it. Note, by the way, that there's an interesting possibility that arises from this. The Shinui Mara HaRochav could actually convert the Rochav hayareach from being northerly to being southerly. For example, if the Rochav was only a half a degree to the north, and the Shinui Mara HaRochav was a full degree down to the south, now the Rochav hayareach is only southerly, not northerly at all. By the way, the Mefarshim ask, why is there no Shinui Mara for the sun? We should also have to account for the fact that we're standing on the surface of Earth, and that should cause a difference in the sun's location. The answer is that the sun is so far away from the Earth that the 4,000 mile difference between the surface and the center don't actually make a difference to where the sun is seen. The moon, though, is closer, and so that difference has to be accounted for. After compensating for the Shinui Mara, we reach the Oirech Sheni and the Rochav Sheni, the second level in the distance and longitude between the sun and the moon, and the second level in the distance and latitude between the moon and the Galgal HaMazoles. And now we're ready for the next adjustment, which the Rambam calls Magal Hayareach. The Rambam describes the need for this adjustment as follows: Mipnei shehayareach noles ma'at b'ma'agolei, because the moon turns or tilts a little bit in its orbit. That's the reason why we require further correction. What does this mean? To understand this, let's delve a little deeper into the concept of Rochav hayareach, the fact that the moon is more northerly or southerly inclined to the Galgal HaMazoles. This fact that the moon is inclined further than the ecliptic requires obviously a correction. If we wanted to say which degree would the moon be in Galgal HaMazoles, we would have to, in simple terms, draw a line from the moon's Rochav to the corresponding degree in the Galgal HaMazoles. If the Rochav was northerly, we would essentially be drawing the line downwards from the Rochav to the Galgal HaMazoles. If the Rochav was southerly, we'd essentially be drawing the line upwards from the Rochav, which is lower, to the corresponding degree in the Galgal HaMazoles. Whatever degree that would reach would basically be the degree that we could define the moon as being at. But there's a slight problem with that when it comes to the moon's sighting. See, the Galgal HaMazoles is also inclined relative to the equator. So to draw a line from the Rochav hayareach to the Galgal HaMazoles would basically be doing that on the axis of the inclined Galgal HaMazoles. But for us, who are worried about the moon sighting, we have to look at the axis of the Galgal Hayomi, which is pushing everything from due east to due west. It's not enough to draw a line from the Rechav Hayareach down to the Galgal Hamazoles. We would have to draw that line in a bit of a different angle to match the longitude of the Galgal Hayomi, so that we could identify which degree on the Galgal Hamazoles will actually set together with the moon. This correction becomes the Oirech Shlishi. And as the Rambam explains, sometimes the Oirech Shlishi will be longer than the Oirech Sheni, and sometimes the Oirech Shlishi will be shorter than the Oirech Sheni. And here's how the Rambam describes it. In the Mazoles Oilim, that means those Mazoles where the moon has a northerly orientation, it's climbing upwards, then if the Roichav, if the moon's inclination is northerly, that will cause a shorter Oirech Shlishi. If the moon's Roichav is southerly, that will cause a longer Oirech Shlishi. However, if the moon is in the Mazoles Yerdim, those Mazoles with a southerly orientation, where the moon, so to speak, is climbing downwards, then the opposite is true. A northerly Roichav will cause a longer Oirech Shlishi, and a southerly Roichav will cause a shorter Oirech Shlishi. Now let me try to explain what this means. If the moon has both a northerly orientation and a northern inclination, then the line that you're going to draw downwards from the Rechav Hayareach to the Galgal Hamazoles is going to meet the Galgal Hamazoles at a more western point. That means on a degree that's closer to the horizon. It's going to set earlier, hence a shorter Oirech Shlishi. However, if the moon has a northerly orientation but a southern inclination, that means we're going to be drawing the line upwards from the Rechav Hayareach to the Galgal Hamazoles, and it's going to meet the Galgal Hamazoles at a more eastern point relative to the point had you drawn that line diagonally, which means it's going to meet the horizon at a later point, hence a longer Oirech Shlishi. When it comes to the southerly oriented Mazoles, the complete opposite is true. When the moon has a southern orientation but a northern inclination, the line you're going to draw downwards from the Rechav Hayareach to the Galgal Hamazoles, this time will meet the Galgal Hamazoles at a more eastern point, setting later, causing a longer Oirech Shlishi. But if the moon has both the southerly orientation and the southern inclination, then when you draw the line upwards from the Rechav Hayareach to meet the Galgal Hamazoles, you will find that it will meet the Galgal Hamazoles at a more western point, a point closer to the horizon, meaning it's going to set earlier, a shorter Oirech Shlishi. Now we can appreciate why the Rambam says that the correction of Magal Hayareach is achieved by taking fractions of the Rechav and either adding it or subtracting it to the Oirech Sheni. Because it's the Rechav, it's the moon's northerly or southerly inclination that's going to determine whether the Oirech Shlishi becomes shorter or longer, as we just explained. Now that we have the Oirech Shlishi, we need to make another correction to bring us to the Oirech Revi. The Rambam doesn't explain the reason this correction is needed, but the Mefarshim do. And I'll paraphrase. When you're standing in Yerushalayim, north of the equator, the more northerly a star is relative to you, the later it will set on your horizon. The more southerly a star is relative to you, the earlier it will set on your horizon. Now consider this. At Shas HaRe'iyah, the night following the Moiled, the moon is definitely more east than the sun. So it's going to for sure set later than the sun. However, depending on the time of year, the moon's lead is either to the northeast or to the southeast. In the Mazoles Oilim, those that have a northerly orientation, the moon's lead is to the northeast. In the Mazoles Yerdim, it's to the southeast, as we also mentioned in the beginning of this shir. Based on the fact that the more north a star is, the later it will set, when you're standing in Yerushalayim, if the moon is in the Mazoles Oilim, besides for setting later than the sun simply because it's to the east, it's going to set even later because it's to the east and to the north. Masha'enkin, when it's in the mazalis yerdim, again, the moon will set later than the sun because it's to the east, but it's to the southeast. So then it will set a little bit earlier relative to the sun. This is the correction that must be made to the oirech shlishi, which is why the Rambam says, between the mazalis of Gedi and Ta'imim, a little bit must be added to the oirech shlishi. Between the mazalis of Sartan and Keshes, a little bit must be subtracted from the oirech shlishi. After this addition or subtraction, we're left with the oirech haravi, the fourth level in the distance in longitude between the sun and the moon. The last adjustment is called the Menas Goiva Hamedina. It follows the same principles of the adjustment before it. Just like to get from oirech shlishi to oirech revi, we understood that the more north the moon is, the later it will set. The more south the moon is, the earlier it will set. We have to also take into account that factually, the moon, whether it's in the mazalis oilim or in the mazalis yerdim, is going to be more north or south of the sun, depending on its rochav. So a northerly rochav, no matter in which orientation, is going to cause an addition to the oirech revi, more north, setting later. A southerly rochav, again, no matter if it's in the mazalis oilim or the mazalis yerdim, is going to cause us a little subtraction, because the more south you are, the earlier you'll set relative to the viewer in Yerushalayim. Hence the name Menas Goiva Hamedina, the angle that has to be added or subtracted because of the height of the country, because of your location in Yerushalayim. Some even say that the Menas Goiva Hamedina is the general name for the last two corrections, even though the Pashtus Lashon Rambam is not mashma that way. But regardless, the point is that this final calculation is to account for the fact that the moon, being more north or south, will set even later or even earlier. And what you're left with after having added or subtracted to the oirech revi is the keshes haraia, the final arc of sighting. This is the final difference in longitude between the sun and the moon. And with this number, you'll be able to finally figure out whether or not the moon can be sighted. The methodology that Rambam uses for this final stage is to compare the keshes haraia to the oirech rishon. Go back to the beginning of the Perek. What was the first level of distance that you discovered in the longitude between the sun and the moon? And now the keshes haraia, the final level in the distance and longitude between the sun and the moon. So first, the Rambam gives us a couple of basic rules. If the keshes, the final arc, is below 9 degrees, don't bother, the moon won't be seen. If it's bigger than 14 degrees, don't bother, it will for sure be seen. Between 9 and 14, the Rambam doesn't say this explicitly, but I'll just give you this rule because it's a very easy way of looking at it. If the keshes haraia is between 9 and 14, then check the oirech rishon. If the number of degrees of the oirech rishon and the keshes haraia are 22 or more combined, then the moon will be seen. If combined they're 22 or less, then it will not be seen. These are called the kitzei haraia, the final limits of the sighting. The limits tell you the combined numbers of the oirech rishon and the keshes haraia to give you the final verdict of whether the moon will be sighted. Of course, in the entire end of the Perek, the Rambam goes through the calculation as it relates to the year that he chose, and wonderfully ends up with a conclusion that the moon will be sighted. Of course, the Rambam concludes the Perek by saying, Ukvar Ra'isa, you've just seen how many cheshbonos, how much addition, how much subtraction goes into these calculations. And that's after we've worked hard, says the Rambam, to come up with a simplified method. Certainly you can imagine how detailed the calculations truly are. And he concludes in the final halacha that the reasoning and the proofs for all of these calculations are clearly delineated in the Sfarim of the Chachmei Yavon, the Greek sages. Even though we don't have the Yiddish Sfarim, the ones that Bnei Yisachar made, it doesn't matter, because since these calculations became known to be true by basic mathematical proofs, we don't trust necessarily the person as much as we trust the Raya Shenisgalsa or the Tam Shenoida, the proof that was revealed or the reasoning that became known.